Okay, so now we are going to move into the arc length corollary. So, in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So the three words that I highlighted are ratio, is equal to, and ratio. So that means we're going to be setting up two ratios and setting them equal to one another. So let's do a little bit reminder flashback. When you have a ratio or a fraction, that represents the part of a whole. So 2/3 of a cup of something means you have 2 out of the 3 parts of that cup. If we're setting these two ratios equal to each other, that means we'll have a part over whole equal to another part over the whole entire thing. So if we relate that to our corollary that we're going to be doing, we come up with our formula. So in a circle, the ratio of the length of the given arc, so the arc length of AB, so that's the part of it, over 2 pi r, which is the circumference. So remember, the arc length is a part of the circumference. So we have the part over the whole is equal to the measure of the arc, AB, over the measure of the whole entire circle, which is 360 degrees. So this is the main formula that you're going to need. So put a box around that formula. So let's explain what these are. Okay, I'm going to use the same colors that I did in the formula to describe what's going on in relationship to the picture. So the arc length of AB is the part that's in dark purple. That's a portion of the circle over the circumference. So the circumference is the whole entire circle. So we have the part over the whole. Okay, so now we're going to talk about the measure of the arc. So remember that the measure of the arc is kind of like if a guy was standing there watching a runner run. He's measuring the distance of the arc. So the measure of the arc is going to be that green portion right there. That's the measure of the arc, divided by the measure of the whole entire circle, which is complete distance around, which is 360 degrees.
All right. We made a mistake in example number 3. If you look at both diagrams, in number 1 it says arc length of AB, and the circle underneath it, well, there is no arc AB. So when we go over these examples, make sure you switch the diagrams appropriately and just pay attention to the one for number 1, the circle on the right, and then for number 2, the circle on the left. So in this example, we have to find and use arc length. So we have to use the diagram to find the indicated measure. So for number 1, if we have to find the arc length of AB, first of all, pay attention to the diagram on the right. Okay, we need to find the arc length. So I'm going to write down my proportion, arc length, which is part of the circle, over the circumference 2 pi r, equals the measurement of AB, which is the arc measure, over 360. Alright, so we have to find the arc length. The arc length goes from A to B, and we don't know what that distance is, so we put an X by it. Everything else we can probably figure out. So then arc length would be X divided by 2 pi, and our radius is 2. So then that ratio is equal to the arc measure AB over 360. So our arc measure is 88 over 360. In order to solve this proportion, or solve specifically for arc length, we have to cross multiply. So our first set of cross products would be X times 360 equal to, the other set of cross products would be 2 times pi times 2 times 88. So then, since we're trying to solve for x, I'm going to divide both sides. I'm going to simplify the right hand side first and get 352 pi. I'm still giving my exact answer. So now I'm going to solve for my x, which represents the arc length. I'm going to divide both sides by 360, which cancels out my 360, so I'm just left with x. So then x would be equal to 0.978 pi. That would be an exact answer. So then if I had an approximation incorporating pi in my answer, it would be about 3.07 meters. Now for part 2 of example number 3, we are focusing on the measurement of arc RS. So we don't want to look at that diagram, we want to look at this one for number 2. So because we want to find the arc measure of RS, we're going to write our proportion, arc length of RS over the circumference. So arc length is still the part of the circumference. And because we have just the radius, it looks deceiving, but the radius is 12.3. So I'm going to use 2 pi r as my formula for my circumference. And that's going to be equal to, that ratio is equal to the measurement of arc RS over 360. Now I'm going to substitute what I know. I know that the arc length of RS is 38. So I'm going to substitute 38 divided by 2 pi, and our radius is 12.3. That's equal to RS. Well, we don't know what RS is. We don't know what the arc measure of RS is. So I'm going to put a variable x on there, and then my 360 still stays there. Now to solve this proportion, I have to cross multiply. My first set of cross products, 38 times 360, ends up being 13,680, equal to my other set of cross products, which is x times 2 pi times 12.3. So I'm going to divide both sides by 2 pi times 12.3. So just to clarify, you could simplify 2 times pi times 12.3, but I just didn't in this case. And so when I divided both sides by 2 pi times 12.3, my 2 pi's cancel out, my 12.3's cancel out, so I'm just left with x on the right side. And that's equal to 177.01 degrees.